April 16th, 2026. The Democratic Republic of Congo, province of Chopo, north-central Africa. The Congo River and two of its tributaries, the Lindi and the Chopo, have burst their banks simultaneously following severe rainfall that began on April 15th. As of April 17th, the International Federation of Red Cross and Red Crescent Societies has confirmed 19 people injured, 13,968 displaced, and 20,000 people affected across the Isangi and Basoko territories. Families are sleeping on rooftops. Roads have ceased to exist. The rescue boats cannot get to everyone. On the same day, on the other side of the world, snow is falling in Seattle, Washington. Not mountain snow, city snow, snow on sidewalks, snow on cars, snow accumulating in South Lake Union and West Seattle and Interbay. A waterspout forms over Puget Sound near downtown. The last time snow fell at Seattle-Tacoma International Airport in April was April 17th, 1972. That was 54 years ago. And meteorologists are explaining that what caused it was cold air that swept down from Alaska, moved over an unusually cold Gulf of Alaska, and drove straight into the city from the west. A collision of atmospheric conditions that, according to University of Washington professor Cliff Mass, forecasting models predicted days in advance, but that nobody expected to hit a city in the middle of April. Snow in Seattle in April, floods in the Congo in April, record blizzards across the American Northeast in February, Australia with 12 locations recording temperatures above 49 degrees Celsius in January, wildfires burning 800 structures in Chile's Bio and Nubel regions in the same month, record warmth in the American West in March, the warmest March on record, across the vast majority of the western United States and nearly all of California. And then, in April, snow again. Something is happening to the global weather system. And tonight, we are going to explain exactly what it is, why the extremes are arriving simultaneously, and what the pattern of 2026 tells us about the years ahead. Let us start with the numbers, because the numbers are the only thing that prevents this story from being dismissed as a collection of dramatic anecdotes. The winter of 2026 is already being recognized by climate scientists and meteorological institutions as one of the most extreme cold season events in modern North American climate history. That is not a media characterization. That is the assessment, published by Century Logic's Intelligence in February 2026, based on observed data across the continent. From early January through late March, multiple major winter systems swept from the southern plains through the Midwest and into the Northeast. Mountainous areas recorded snowfall exceeding 30 inches. Parts of the northern Midwest experienced temperatures plunging below negative 40 degrees Fahrenheit. That is negative 40 degrees Celsius, the point where both scales converge, marking some of the coldest readings in decades. In late January, a powerful multi-day winter storm moved from the southern plains through the Midwest and into the Northeast, triggering more than 170 deaths across northern Mexico, the United States, and Atlantic Canada. New York City endured single-digit temperatures with wind chills well below zero, forcing emergency warming measures and overwhelming shelter services. Chicago, Detroit, Toronto, Montreal, all of them under sustained cold that strained power grids, froze transit systems, and buckled aging infrastructure. And then, on February 23rd and 24th, a nor'easter hit the northeastern United States, Blizzard 26, that produced snow totals approaching 3 feet in Providence, Rhode Island, breaking that city's all-time record for the biggest snowstorm and snowiest single day in its recorded history. Not the record for February, the all-time record, ever. Providence has been keeping weather records since 1843. Nothing had ever matched what fell in a single day in February 2026. In March, a blizzard swept the high plains to the Great Lakes from March 15th to March 17th. California and the broader American West, meanwhile, were experiencing the exact opposite. The warmest March on record across the vast majority of the region, with snowpack in most areas near or below all-time record lows for early April. World Weather Attribution, the scientific consortium that rapidly attributes extreme weather events to climate change, stated that March 2026 heat waves in Western North America were events that would have been, in their exact language, quote, virtually impossible without human-induced climate change. Then April arrived. And instead of warming, 45 million people across the Midwest and Northeast faced another cold blast. And Seattle got snow for the first time in April since 1972. And the Congo River flooded, and heavy thunderstorms hit the provinces of Lao Cai, Gia-Lai, and Lam Dong in northwestern Vietnam on April 15th and 16th, causing casualties and damage. And above-average rainfall was being forecast across northern and eastern Angola, central and western Zambia, and northern, central, and eastern parts of South Africa for the week of April 16th to April 22nd. This is not a list of isolated incidents. This is a pattern. To understand the pattern, you have to understand the mechanism, because the mechanism is not what most people think it is. Here is what nobody is telling you about the relationship between record cold events and record heat events in 2026. Most people assume they are opposites, that record snow in April means the climate is not warming, and that record heat in California means the cold events are anomalies. This is the fundamental misunderstanding at the center of most public confusion about extreme weather. The actual scientific relationship is the opposite. The warming of the planet is not producing uniform warmth everywhere simultaneously. It is producing instability, an amplification of the swings between extremes that makes both the hot events hotter and the cold events more surprising in their timing and intensity. The specific mechanism is the polar vortex. The polar vortex is a band of high-speed winds that circulates around the Arctic at high altitude, containing cold polar air. In a stable climate system, this vortex is strong and coherent, keeping Arctic air locked in the polar region. But as the Arctic warms, and the Arctic is warming at roughly 4 times the global average rate, a phenomenon scientists call Arctic amplification, the temperature difference between the polar region and the mid-latitudes decreases. And as that temperature difference decreases, the jet stream weakens. And as the jet stream weakens, it becomes more prone to large amplitude waves, the kind that meteorologists call Rossby waves, that can send polar air deep into mid-latitudes and simultaneously pull warm air far north. This is the mechanism that explains both the negative 40-degree Fahrenheit temperatures in the northern Midwest in January 2026 and the record warm March in California in the same season. They are not contradictions. They are 2 consequences of the same disturbance. The same wobbling jet stream that drove Arctic air into the Midwest in January created the ridge that pushed record warmth into the American West in March. Professor Cliff Mass of the University of Washington described the Seattle April snow event with technical precision. Cold air moved in off Alaska, traversed an unusually cold Gulf of Alaska without warming, and then drove directly into the city from the west. He used the event to make a broader point about forecasting accuracy. The models predicted it days in advance, which is itself a sign of how much atmospheric science has improved. But the event's cause, a cold air outbreak from Alaska reaching into the Pacific Northwest in April, is consistent with the pattern of amplified jet stream waviness that climate scientists have been documenting throughout this decade. Now add the moisture component. Because the other half of the extreme weather story in 2026 is not cold, it is water. Too much of it, in the wrong places, at the wrong times. The physics of this is equally direct. A warmer atmosphere holds more water vapor. For every 1 degree Celsius of warming, the atmosphere is water carrying. Capacity increases by approximately 7%, following the Clausius-Clapeyron equation. This means that when it rains more intensely. When it snows in an anomalous cold outbreak, the snow is heavier because there is more moisture available to fall. And when a weather system stalls over a fixed location, which, in an era of weakened jet streams and more meandering atmospheric patterns, happens more frequently, the rainfall totals in that location can exceed anything the historical record contains. Flooding has become what the United Nations Office for Disaster Risk Reduction describes as the world's foremost climate hazard. The numbers are staggering and they are not improving. Between 1970 and 2019, water-related hazards accounted for 50% of all recorded disasters and 45% of all reported deaths globally. Since the year 2000, the number of recorded flood-related disaster events has risen by 134% compared to the 2 previous decades combined. 134%. And that trend has continued. In July 2025, 9 months before this broadcast, a devastating flash flood in central Texas claimed the lives of at least 135 people when the Guadalupe River rose 31 feet in 90 minutes, making it the deadliest inland flooding event in the United States in almost 50 years. In 2025, across Pakistan, more than 700 people were killed by floods triggered by torrential rains across multiple provinces. In October 2025, floods in Mexico killed at least 66 people and damaged more than 16,000 homes. In 2026, the global pattern of flood events has not slowed. Congo's Maniema province experienced heavy rainfall from late March, triggering floods described by the FuseNet Global Weather Hazards, summary as deadly and damaging. On April 15th, severe rainfall hit the province of Chopo in north-central DRC, causing the Congo River and its tributaries to overflow, displacing nearly 14,000 people and affecting 20,000. Simultaneously, above-average rainfall conditions were active across multiple regions of southern Africa, Central America's Atlantic coast, and Central Asia, with moderate to heavy precipitation in northeastern Afghanistan, northern Pakistan, eastern Uzbekistan, western Tajikistan, and southwestern Kyrgyzstan, all raising flood concerns in a region that has seen repeated inundation events over the past 30 days. Here is the compound nature of the flooding crisis that makes 2026 different from previous flood years. It is not just that there is more rainfall. It is that the infrastructure receiving that rainfall was never designed for the rainfall intensities now being recorded. Urban landscapes across the developing world, and increasingly across the developed world, were built on engineering standards derived from historical rainfall data that no longer reflects what the atmosphere is actually doing. Flash floods surge through cities because storm drains designed for a 50-year rainfall event now face 100-year or 200-year events on a routine basis. The Al Jazeera analysis of the global flooding crisis, published at the end of 2025, captured the mechanism precisely. The global warming driver meets local vulnerability. Urban landscapes fundamentally unequipped for the new reality. The result is a surge in flash floods where overwhelming water meets inflexible design, and as Ayub Sharifai, professor and urban scientist at Hiroshima University, told Al Jazeera, while climate change intensifies the events, urbanization, deforestation, inadequate infrastructure, and poor river management all amplify the damage. The economic numbers are equally alarming. The UNDRR's Global Assessment Report found that riverine and overflow floods produce average annual losses of $188.4 billion globally, including $74.1 billion in direct losses. More than 14 million properties in the United States alone face previously unrecognized flooding risks when modern rainfall intensities are factored into risk models, far more than conventional planning and insurance frameworks account. 4. The flood risk is not coming. It is already here, already priced into insurance markets, already overwhelming disaster response systems, and already producing human displacement at a scale that dwarfs any single conflict. Here is the catch that makes this story more complex than a simple global warming narrative. Climate Central published a critical analysis in January 2026 that contains a number worth pausing on. Through January 26th of this year, major United States cities set over 4 times more daily record high temperatures than daily record low temperatures. 171 daily heat records against 40 daily cold records across 247 cities, 4-1. In a system with no climate change, you would expect roughly equal numbers of record highs and lows over time. The 4-1 ratio of highs to lows is the fingerprint of a warming climate, showing through even in the middle of a winter that produced record blizzards and negative 40-degree temperatures. The coldest day of the year has warmed by 7 degrees Fahrenheit on average across 242 United States locations since 1970. 7 degrees. The winters are shorter, the cold extremes are less frequent, even as individual cold outbreaks, when they do occur, can still be dramatic and deadly. World Weather Attribution's rapid assessment of the March 2026 Western North American heat event stated it plainly. These heat waves would have been virtually impossible without human-induced climate change. The same consortium has been applying this attribution methodology to extreme events for years, and the pattern of their findings is consistent. The record heat events are becoming more frequent and more intense in direct proportion to the warming signal, while the record cold events are becoming less frequent but remain capable of producing significant impacts when they do occur, specifically because a warming Arctic destabilizes the jet stream and allows occasional deep polar air outbreaks into mid-latitudes. And here is the detail that connects the snow in Seattle to the floods in the Congo in a single analytical frame. Both events are expressions of the same underlying atmospheric instability. The Pacific typhoon that meteorologist Daniel Swain and his colleagues were tracking in early April 2026 was producing what Swain described as an unusual set of tropical cyclones over the western Pacific. A pattern he specifically noted was likely to substantially perturb the Pacific jet stream and lead to what he called, in his exact language, various flavors of North Pacific drama by increasing the amplitude and waviness of the overall flow pattern. That perturbation, a typhoon recurving into the mid-latitude flow, is the same kind of event that can simultaneously drive cold air outbreaks toward the Pacific Northwest and generate moisture surges over equatorial Africa. It is one planetary system. The disturbance in one part sends ripples to the others, and in a warmer, more energetic atmosphere, those ripples are larger. Weather West's Daniel Swain wrote at the start of April 2026 that the month was shaping up to be substantially more active, storm-wise, than March, with temperatures alternating between warm and cool as weather systems move through more rapidly. He forecast quite respectable precipitation along the west coast and in the central and northern Sierra Nevada over the next 10 days, 2 to 3 inches of liquid equivalent widespread precipitation across coastal and Central Valley California. A partial reprieve for a region where snowpack had been near or below all-time record lows for early April after the record warm March. But he also flagged a specific concern. A strong West Pacific typhoon was likely to recurve into the mid-latitude flow by mid-April and generate what he called a powerful late-season Pacific jet extension. And when this pattern emerges in spring, as it has done repeatedly in recent years, it generates strong to extreme ridge and trough anomalies between Japan and the western United States, the kind of pattern that produces volatile, hard-to-predict weather sequences across the entire hemisphere. For flood-prone regions across Central Africa, Central America, and South Asia, the FEWS Net Global Hazard Assessment for the week of April 16th to April 22nd is direct. Flooding is a concern, not a possibility. A concern. In Afghanistan, Pakistan, Uzbekistan, Tajikistan, and Kyrgyzstan, moderate to heavy precipitation is forecast, following a 30-day period of above-average rainfall that has already saturated soils and raised river levels. In the Atlantic-facing regions of Central America, eastern Honduras, northeastern Nicaragua, Costa Rica, Panama, heavy rainfall has been occurring throughout April and is expected to continue. These regions lack the drainage, infrastructure, the early warning systems, and the emergency response capacity of wealthier countries. When rivers rise in these areas, the damage is not measured in insurance claims. It is measured in lives and in displacement that can last years. Here is the number that frames the human cost of all of this in its full scale. The number of people exposed to floods globally has risen from 28.1 million in 1970 to 35.1 million in 2020, an increase of nearly 25% in 50 years, driven by population growth in flood-prone areas, by urbanization that covers permeable ground with impermeable surfaces, and by the increasing intensity of rainfall events themselves. On current trends, that number is not decreasing. The infrastructure investments required to genuinely reduce global flood risk, comprehensive watershed management, slope stabilization, modern urban drainage systems, early warning networks in developing nations are orders of magnitude larger than what is currently being committed. The gap between the risk and the response is widening, not narrowing, and 2026 is where you see it most clearly. 14,000 people displaced in the Congo on April 15th, while Seattle gets snow for the first time since 1972, and California's Sierra Nevada rebuilds its snowpack after the warmest March on record, and 45 million Americans are under cold advisories in mid-April. The global weather crisis of 2026 is not a future problem. It is a current emergency that is presenting itself in forms that are simultaneously more dramatic and more confusing than most people expected. Record snow in April, in a city that has not seen April snow in over 5 decades, is not evidence that the climate is not warming. It is evidence that the climate is destabilizing, that the atmospheric patterns which once produced predictable, seasonal, regionally appropriate weather are now producing events outside their historical envelopes, in unexpected locations, at unexpected times, driven by a planetary energy imbalance that has been accumulating for decades and is now expressing itself in the weather that lands on your doorstep. The binary is not between doing something about climate change and not doing it. That debate, for practical purposes, is over. The warming is happening, the attribution is clear, and the cost of inaction is now being measured in real displacement figures and real dollar losses that dwarf any projected cost of mitigation. The binary is between an approach to infrastructure, early warning, and emergency response that is designed for the climate of the 20th century, the climate under which our cities were built, our drainage systems were engineered, our disaster response frameworks were written, and an approach redesigned for the climate of the 21st century, where a Pacific typhoon in early April can simultaneously trigger a late-season jet extension that brings snow to Seattle and amplifies the moisture loading that turns an African rainfall event into a 20,000-person displacement. The weather is speaking. In Seattle, snow. In Congo, floodwater. In Providence, blizzard totals that broke records that had stood since 1843. The question is not whether we hear it. The question is whether we have the will and the institutional capacity to respond before the next record falls. And based on everything that 2026 has already shown us, that next record is not far away.